Hello everyone, welcome to the final segment of our first module on the basics of measurement. We'll be talking about conversions. So there is one learning objective for this segment: perform calculations involving derived units such as area or volume, involving conversions between base units and prefixes. While this appears to be fairly straightforward and there's only one learning objective compared to the multiple we had for the previous segments, this is probably the most important thing to learn this semester, how to convert between different units. Hopefully we were able to spend some time on the first in-class day to go through some of this, and as we go through this again, if you want to skip through those parts, feel free to do so. However, I want this to be a resource you can come back to again and again to remind yourselves of how this works. When we solve problems with unit conversions, the focus is on the units. Most of the math we do in science courses and science in general can be determined by paying attention to the units. We're showing an example here using the SI system that we've already talked about. So converting 285 milliliters to liters, we're showing how we can write the definition of the milliliter such that those units will cancel out. So the units are canceling to give us the units that we want in our answer. Couple of guidelines on how to do this. Sort the information that is provided in the problem itself. Sometimes the problem will give you all the information you need, and sometimes you need to find additional information in order to solve the problem. That additional information could be either explicitly stated somewhere, perhaps in a table, that you need to reference, or you might need to infer that information from what is provided. So although the basic steps we're looking at today, we'll keep following those steps throughout the semester, this part is where there will be some differences. This is where you will have to make some decisions as we learn more about chemistry. Once you've made your table of data, of your information, come up with a plan on how to solve the problem. Most of the time, the best plan is to come up with what we're calling a solution map. This is focused on the units, so you're looking at how the units are telling you to solve the problem. Once you've done this, you might realize that you need additional information you didn't initially expect that you needed. If that's the case, go back and find that information, put it in your table. So you might have to kind of go back and forth between this set of steps and this set of steps. Sometimes you can even work backwards. You can know, okay, I need these units at the end. I know this thing will help me to get there. And you can put in maybe that last step, and then that helps you get from the initial steps to your final step. Then you solve the problem. As you're doing this, make sure you're paying attention to the units. So this is essentially where you're going through canceling out units, plugging numbers in your calculators, and you get a number at the end. Now that's not the end. The end is not a number from your calculator. You need to check your work. Make sure that it makes sense. Make sure that your answer is reasonable. Sometimes we will talk about some answers that might make more sense than others. So some answers that fit in might fit in a certain range, and you can check if your answer is within that range. You can definitely check, do you have the right units? Are they the units that you should have for the question at hand? And when you go through your solution map, do all the units cancel out that need to cancel out? And then finally, just double check that you have the correct significant figures. Okay, so as I mentioned, I want to go through some examples. And again, hopefully we had a chance to do some of this in class already. If not, here's your example. And if you, after doing this, you feel very comfortable with it, feel free to skip ahead to the remaining ideas at the end. There is additional new information today, so don't skip the whole video. But feel free to skip ahead past this problem if you already know how to do it. Go ahead, take a minute, see if you can solve this problem, and then I will go through my answer key. Okay, so here is our question. I lived in Seattle, and so I know a little bit about this guy, Ken Griffey Jr., and if you want to know more about his road trip, feel free to Google it, and you'll find out. So Ken Griffey Jr. drove from Baltimore to Orlando in May 2010. How much did he pay for gas? And there's some information here. I don't know specifically that this is what he was driving, but we can just assume for the sake of this problem that he had a 2010 Mercedes-Benz, and we can say that if it has 22 miles per gallon, let's write it this way. 22 miles equals 1 gallon. Okay, so the next line here, East Coast gas price in 2010, $2.98 a gallon. I'm going to, again, write it the same way, $2.98 equals 1 gallon. And again, what we're doing, we're writing these as equalities. If we can write it as an equality, that's what we want to do. And then the last line, Baltimore to Orlando, is 892 miles. That one we cannot write as an equality. That is simply a number. That's just a statement. That's our measurement. And when you go through and you make this sort of table with information, you're going to have one number. You'll often have one number that only has one unit. It's not an equality. And that is the number you want to start with. So we're going to start with 892 miles. Because it is a number by itself. It is not an equality, and we'll see why that will be helpful as we go through this problem. There will be a point when we don't, later in the semester, when we don't always have this as a possibility, but when we do, we want to make use of it if we can. So we put 892 miles, and then we look for where do we have units of miles. We see miles are up here. So we put 22 miles on the bottom, 1 gallon on the top. And then we look for where do we have units of gallons. We have gallons here. We put $2.98 on the top, $2.98, and the 1 gallon on the bottom. Okay. So what we've done is we've let the units tell us how to solve this problem. So the miles cancel and the gallons cancel, so those units are canceling. So what we do is we multiply across the top, so 892 times 1 times 2.98, then divided by 22 divided by 1. The ones that, of course, you can leave out. And when we do the math there, we get $120. Okay? And that is two significant figures here because we had two significant figures up here. Okay, does this number make sense? It seems reasonable. If we had gotten like $1,000 or if we had gotten like 10 cents, then we would know we're probably on the right track because we have an idea of what to expect for these sorts of numbers. Also, along that line, many of you, probably most of you, are comfortable doing this type of calculation because it's something that applies to your everyday life. And maybe you could do it without using this method. I want you to try to use this method because this is the method that we'll be using this semester. So you can kind of convince yourself that you can solve a problem using this method, even if it is, so that you can use it when it's a problem that you don't understand. Speaking of which, let's look at a problem where maybe we don't know what the units mean. Okay, so we want to apply the same idea here. Go ahead, pause the recording, make sure you can do this problem, and then turn it back on and you'll see my answer for this. Okay, so let's go ahead and read the question. How many willows are there in 24 pillows if you know that there are 8 pillows in a billow, 15 billows in a zillow, and 45 zillows in a willow? Now, obviously, this doesn't make any sense. This doesn't mean anything. The purpose for this question is if you ever get to the point where you are asked to solve a math problem in this class where you don't think it means anything, you don't understand the meaning of the units, you are able to do that because you know the process. So again, the first thing we want to do is we want to go through and make a table of useful information. And as we go through that table, we will then use that to solve the problem. So first thing, I'm going to write question mark. So how many willows? We're looking for willows in our answer. So we'll start with that. And there are 24 pillows. Okay, so that's a statement. So how many willows are there in 24 pillows? If you know that there are 8 pillows in a billow. Okay, so I'm going to write that as an equality. 8 pillows equals 1 billow. Okay. 15 billows in a zillow, so I'll write that as well. So 15 billows equals 1 zillow, and 45 zillows in a willow, so I'll write that one down. 45 zillows equals 1 willow. Okay, so that's our table of information. So we have 3 equalities, we have a question, we have a we have a number by itself. Okay, as always, we want to start with a number by itself, if that's a possibility. So we say 24 pillows, and then we'll say, we'll look for where do we have pillows? Where do we have pillows show up? We have pillows right here. So maybe we'll cross these out as we use them, so we've used this equality. We put the pillows on the bottom, and the 1 billow on the top. Okay, so again, the reason we're doing this, we want the units to cancel. So that's the reason for that. Okay, next up we have billows. We want to get rid of billows. We see right here, we have an equality, 15 billows equals 1 zillow. So we'll go ahead and do that. So we put the 1 zillow on the top and the 15 billows on the bottom. Okay, so we've used that one. And then finally we have 45 zillows equals 1 willow.